Right, so let's look at our first question. We have if 3 to the power of x plus 1 plus 3 to the power of x minus 1 is equal to 20 is simplified, then x is equal to log base w of t. Find a possible value for w and t. Right, so I just want to begin by focusing on this bit over here, because this is going to give us, I think it's going to give us a goal to work towards, right? So x is equal to log base w of t, right? We want to rearrange this guy so that we end up with something like that guy over there, right? So the question is, how do we go about that? And we know that logs and exponents are inverse operations of each other, right? So we know that if a to the power of x, I don't want that, I want something thicker. Okay, let's try that again. So we know that if a to the power of x is equal to y, that means log base a of y is equal to x. In other words, the log asks, to what power should I raise a in order to get y? And the answer is x, right? So using that idea, we can rewrite this expression over here, right? If x is equal to log base w of t, then that means w to the power of x is equal to t, right? And so now I feel like we're kind of getting a sense of what we need to do with this equation over here, right? We want to get it from looking like this to looking like that. Oh dear. Okay, right? And that's promising because we can see in this equation over here that we're starting with that we do have x's in the exponents, right? And so it's a matter of somehow getting the left-hand side to become one term, and then saying that's equal to some number on the right-hand side, right? So I'm just going to grab this over here and put it to the side. Oh, I don't want to take the arrow with, but anyway, we'll just take it along, right? And I'm going to put that there as kind of our guiding light. This is what we're trying to get to. Let's use a color like pink. Okay, so that's kind of our goal, that's our dream, right? So there's a key thing that I mentioned, right? I said in this equation that we're starting out with, we want to get this left-hand side to be one term, right? So we currently have two terms on the left-hand side. We have 3 to the x plus 1 and 3 to the x minus 1. And we want to somehow make that into one term. And whenever you are faced with a problem like that, where you need to take multiple terms and make them into one term, one of the things that should come to mind is factorizing. So think about, how can I factorize this expression? Because factorizing collects multiple terms into one term. So this is where we can use our laws of exponents, right? So we know that a to the power of x plus y is the same as a to the power of x times a to the power of y. So we can use that fact to express each term on the left-hand side as a product of two things, right? So let's do that. So we have 3 to the power of x plus 1, which is just the same as 3 to the power of x, times 3 to the power of 1. And then our next term, oh guys, I don't know why me and my pen be struggling with straight lines, but please bear with us, right? So the next term will be 3 to the power of x times 3 to the power of minus 1. And that is equal to 20. Right. So let's get rid of this guy. Okay, let's move this guy up. Right, so what do we then notice? We notice that our two terms actually have a factor in common. They both have a 3 to the power of x in common. So we can factor that out. Oh, I'm going to get rid of my highlighter. Hey. Okay, guys, just a heads up that there is probably going to be such a steep technology learning curve for me with this app, with this pen. This iPad is also just, it's done its yards, man. Anyway, please bear with me. Okay, so we can factor out 3 to the x. In the first term, we'll be left with 3 to the 1. And in the second term, we'll be left with 3 to the minus 1. Right, and that is equal to 20. Right, so we're almost getting there, right? So this 3 to the x is looking very exciting, okay? And what we're left with in the brackets, it's important to notice that this is just a number. It's a weird looking number, but it's a number. 3 plus 3 to the power minus 1, or just 3 plus a third. So we can work out what that number is. So where my calculator at? Okay, need to find my calculator real quick. Okay. Oh, this is a busy calculator, sheesh. Right. Okay. Right. So we want to work out what this number over here is. Okay. So we're going to punch it in. 3 to the 1 is just 3, and 3 to the minus 1 is a third. Okay, so that gives us 10 thirds. So we've got 3 to the x times 10 over 3 is equal to 20. Right, and now in order to get 3 to the x by itself, we can divide both sides. Okay, just going to show that with a thinner pen. We can divide both sides by 10 over 3. Right, so we're going to do that on this side as well. Right, so on the left hand side, we'll just be left with 3 to the x. Yo, the flames. Right, so on this side we'll just be left with 3 to the x, and on this side we can work out 20 divided by 10 over 3, and that just gives us 6. And voila, we have arrived at the promised land. Can I hide this calculator? Go away. Oh no, it's not hidden, it's just big on the side. It's probably not a terrible view, hey? Anyway, right, so very excitedly we have arrived at our promised land, which is kind of hidden by this guy right now. But remember that the goal had been to get to a place where we have some number to the power of x is equal to another number. And we would know that the base is w and the number on the right hand side is t. So we can now say that w is equal to 3 and t is equal to 6. And there is our solution. Right, and the nice thing with algebra is that you can then test whether your values make sense. In many algebra questions this is possible, right? So what we have discovered is that x is equal to log base 3 of 6. And if I work out what that is on my calculator, that is log base 3 of 6, right? That is 1,63 something, right? And what we are saying here, or what we've discovered, is that if we take this number and we replace the x's in that initial equation with this number, then we should get 20, right? And this is how we can know that we have in fact arrived at the correct answer. If we put our x into the equation and we end up with some other number that isn't 20, then we can know that, oof, I might have gone wrong somewhere. Let me check my steps. So let's in fact test if we're going to get 20. And out of sheer laziness, I'm going to commit one of the biggest sins in mathematics, right? I'm not going to use the exact number that I've gotten on the calculator, 1,630. You really should. When you're doing your testing, you should always use the accurate number, okay? But I'm going to use the rounded number. We should still get a number very close to 20, okay? So let's see if we are correct, if our workings are correct. So 3 to the power of 1,63 plus 1, okay? And then we're going to add 3 to the power of 1,63 minus 1. Right, and you see there the answer that we got is 19,97, very close to 20. So then we can kind of be confident that we might have done our stuff right. And just to confirm with the memo, yep, W is in fact 3 and T is equal to 6.